We are now ready to explore the laws of logarithms. Now, the first four are ones that we can prove through switching back and forth between exponential and logarithmic forms. The last three will be ones that we're going to use the investigation that we did earlier to summarize things that are true there. We'll also do some proofs with that. For those of you going into 4U math, this is a heads up to further things that we will be doing there. All right, the first log law that I would like to talk about is the fact that the log of 1 with a base of b is equal to 0. Okay, so that's a base of b here. Now, if we think about writing that in its exponential form, we know that b is our base, so b, the 0 is our exponent, to the 0 would equal the argument, which is 1. And that is a true statement. So this is a true, the law itself, the log of 1 with a base of b equals 0, is a true statement. So that's the first log law. The second one says that the log of b with a base of b, log base b of b, that would equal 1. And again, if we change that into its exponential form, we would take the b as our base to the exponent, the 1, and that would have to equal the argument, which is b. And b to the 1 is equal to b, so yep, that is a true statement. So there's the first two. On to the next one, the third one. The log, this one looks a little bit fancier, but very similar. The log of, with a base of b to the exponent n will just equal n. Okay, so if these two pieces here are the same, then we can just say the log of those two pieces being the same will just equal the exponent there. All right, so if we were to take this time and put it in its exponential form, we would take b as our base, the n is the exponent, and that would have to equal the argument, and this piece is the argument. So that would equal b to the n, and we just wrote a true statement. So there is our next law. The fourth one says that if I have, and it goes the other way this time, I have a base of b, and the exponent that's on there is the log of x with a base of b, that would equal the x. Now this one looks tricky, but again, we're going to just switch it. Think of this as being exponential form, where we have b as our base, and the exponent, this piece is the whole thing is the exponent, and this is our answer of x. This is exponent. We're going to rewrite that in its logarithmic form, and when we put that in the log form, we're going to have the log with a base of b of the answer, x, would equal our exponent, which is the log of x with a base of b. And there we have another true statement. So this is something that's always true. Now we're going to use some of these in our next proofs. Number 5 gets into the one that you explored during the investigation, and you should have found that if you have the log of m plus the log, whoops, I'll put a base of b on there, the log of n with a base of b, that is just the same thing as the log with a base of b of m times n. All right, now we are going to do a proof here too. A little proof on this, our proof. It's going to look like this. We are going to take the log of m with a base of b, and we're going to let x equal the log of m with a base of b, and we'll let y equal the log of n with a base of b. All right, now let's see what we can do with this. I'm going to take this first section here, and we're going to rewrite that in its exponential form. That would give us b to the x would equal m. And from this second part here, b to the y would equal n. Okay, now from here, I'm going to start with the the right side of the equal sign. I'm going to start with this more complicated, or the more condensed format of this. I'm going to take the log of b, log base b of mn, and I'm going to rewrite that as, or that would be equal to, now we know that m here is equal to b to the x, so that b to the x is going to replace the m, and n is equal to b to the y, and the b to the y will replace the n. So that becomes the log of b to the x times b to the y. There we go. Replace that. Now, exponent rule says when your bases are the same, which they are, and you're multiplying, the rule is that we're going to add those exponents together. So we have b, we're going to get a base of b, and then our exponent would be x plus y. And then I'm going to look at log rule number 3. I'm just looking up above here, log rule number 3. I know that when these two things are the same here, right here, that this, the log of this, will just equal that exponent. So that's going to equal, and I'm running out of room here, I'm just going to go over here and borrow room from number 6, equals x plus y. Now, we're not quite done. We're almost done though. X, we defined that at the beginning to be equal to, defined it at the beginning right here, to be equal to the log of m with a base of b. So that would be equal to the log of m with a base of b, and then plus, and then the next one is y, and y we also knew from the beginning, we let y equal this, so that will be plus the log of n with a base of b. So we have now proven that log law is true. All right, so number 6 is very similar to number 5, except it's the subtraction of that. The log with a base of b of m, take away the log with a base of b of n, is equal to the log with a base of b of m divided by n. All right, and again, you investigated that. It has a very similar proof to the one we just did, so I'm not going to actually walk through that proof with you. You can try it if you would like, to see if you know how to do that, but trust me on that, it does work, and you did the investigation to show it worked. All right, next one, last one here, lucky number 7. This is the power law of logs. The number 5 and number 6 were the product law of logs and then the quotient law of logs. So if you want to go back and add that into those, just so that you know what we're talking about. So the last one is the product law of logs, and what it's, the power law of logs, and what it says is if you have the log of b, log base b, darn it, so that's supposed to say log base b of m to the exponent n. We'll make that a little letter n this time, so that's the log. What that says is that's equivalent to n times the log of m with a base of b. All right, now again, we're going to do a proof for this. Quick little proof. Interesting little proof. What we'll start with is we're going to let x be equal to the log of m with a base of b. All right, and then we're going to start with the fact that we have, so therefore, the log of m to the exponent n with a base of b, that could be written as, oh, wait, before we do that, I missed a step here. If I take that x equals the log of m with a base of b, if we rewrite that in its exponential form, we would have b to the exponent x would equal m. That's what I needed to do. And then we're going to use this m, the fact that m is equal to b to the x, and we're going to replace the m here with a b to the x. There we go. Now I've got this. All right, so that m goes in here. It's b to the x now, so the m, and then that's to the n. There's the exponent rule that says we're going to multiply those exponents together, so we get the log with a base of b of b to the exponent x times n. Wait, that doesn't look like an x. There we go. Let's try this again. X times n. Now, that log law we tried earlier, or talked about earlier, when these things are the same, that's just going to equal x times n. And x, we said earlier, was equivalent to the log of m with a base of b. So this means we have n times the x, or n times the log of m with a base of b. Remember, the order of multiplication doesn't matter. This is the same thing as n times x. Those are equal there. All right, so I just put the n first and then the x second. So those are our basic log laws that we will use to simplify logarithms.